Hello, I'm Dennis Spaeth, the publisher of Cutting Tool Engineering, and we're here today for Ask CT Contributors, a webinar series that we like to do so that our audience can learn more about the articles that are written for our magazine, either by the contributors themselves or the people that we interview for those articles. And we focused on the Flying Five, and part of the core competencies of meeting the needs of the aerospace industry. We had a sidebar that ran with that this past month, and it's called Making the Grade, which was contributed by Sandvik Coromant. And today we have joining us Tom Funky, and he's a senior CAM and application engineer for Sandvik, and he's worked with many aerospace customers on CAM tooling solutions. For most of his 15 years with Sandvik Coromant, he has worked with a dedicated team that supports the aerospace manufacturing industry. In his role, Tom focuses on creating CNC machine processes, utilizing the latest tooling technology and CAM programming techniques. Tom has also held positions as CAM manager of a tooling production facility and as an engineering manager of a process engineering team. And he's located in the Detroit area. So Tom is going to take it away and share a slideshow with us. And at any point, if anyone wants to ask questions, you feel free to submit them through the chat window, and we will keep track of them, maybe interrupting as we go to ask questions. But for sure, we'll have a Q&A at the very end. So Tom, take it away.
All right. Thank you so much, Dennis. Hopefully you can see my PowerPoint first slide there.
Yep.
Let me know if not. But no, thank you so much. Greatly appreciate the time and being able to present for Cutting Tool Engineering. But as Dennis was mentioning, this PowerPoint is going to be based on a couple of articles that were done for this month's issue. And we're going to incorporate those into a presentation that's going to go over all things aerospace machining that encompasses a multitask machine or a 5-axis machining. And then we're also going to incorporate some Sandvik solutions into that. So I'm going to first start off with talking about a couple of turning grades that we're going to highlight, then go into 3+2 turn machining, into full simultaneous 5-axis turn machining, and then dive into some 5-axis milling, including ceramic milling, along with turn milling and some point milling for turbo machinery, and then even discuss some really interesting solutions for skiving on multitask machines. So again, about me, my name is Tom Funky. I've worked with Sandvik Coromant for 15 years, primarily with the aerospace team. What that is we're a unique team that works with our customers in the industry, and we assist them with manufacturing parts better, faster, more secure, and just kind of push the industry in a positive direction in that regard. Just to give you guys a sense of the scope of who we are, we're a global Swedish company. We have offices all over the globe, so anywhere that there's manufacturing being done, we're there. On the screen right now, you're seeing a map of our aerospace team and how we're spread out across the world. My specific team in the U.S., we cover aerospace along with space exploration and defense. So anything involving anything related to aerospace, space, and defense, we get involved in that. To give you an idea of some of the parts we work on, it's basically any part that goes into an airplane or rocket or anything in between. So that could be engine components, fan discs, engine casings, turbine discs, IBRs, shafts, pistons, any multitude of frame components. And those materials could range from anything from nickel alloys to titaniums to stainless steels to composites, aluminum, magnesium, and everything in between. So quite a range there that we all work on with the aerospace industry. Okay, so kind of just diving right into it, as it pertains to, again, those articles that were discussed this month for Cutting Tool Engineering. I wanted to kind of dive right into some of the benefits of using a 5-axis machine, and then some Sandvik solutions that we have. So as you may already be aware, a 5-axis machine is fantastic in that you're basically taking a multitude of machines and combining them into one. So no longer do you need a separate turning machine and a milling machine, or a VTL and a HMC, or a shaping machine and hobby machine. You can combine all those machines into one in a multitask machine. Along with that, you can do things done in one, so they say. So with the addition of a sub spindle, you can do multiple setups automatically and be able to machine both sides of a component, relieve the stresses in it, transfer it back to the main spindle and back and forth until you're completed with that project. You can also incorporate gantries and robotics and automatic loaders so that you can do, true lights out machining. So definitely the future. It's no surprise that I'm sure those on this webinar have seen it come into fruition more and more over the years and decades. And it's, definitely trending in that direction. So first, I'm just going to dive right into it and just show some solutions that we have as it relates to 5-axis multitask machines. In the article, it was briefly talked about a specific grade for turning, and that grade is called S205. So what this is a new generation insert grade that we use for turning for aerospace components. It's specifically for nickel alloys. So think like wasp alloy, Rene, Inconel 718, Inconel 625, anything that's like a nickel alloy HRSA material. This insert does fantastic at. So it replaces our previous generation, and the benefits of it is that it can basically run 30 to 50% faster. And our old generation was extremely competitive out in the marketplace. So again, I wanted to just bring this grade to your attention before we move on, and just kind of uh, bring education, like an educational service to our customers about what's now available and what can be done in the industry. So it's kind of eye-opening when you see some of these slides coming up on what it can accomplish. So it is a CVD grade. It is excellent for roughing and finishing. You can use it for any multitude of parts like you see on the screen: shafts, casings, turbine discs. Um, it kind of falls in placement between some other solutions that we already had. Our previous generation SO5F, you can see, sits below it at a slower cutting speed. And then they go even faster. You would have to go move on to something like a CBN grade. But with CBN for nickel alloys, that's only really used for finishing. You only want to use it for a small, like 5 thou, 10 thou finishing pass. Whereas the S205, you can use it for roughing, semi-finishing, and finishing. Another comparison again from the old grade to the new grade. You can see in the orange line, based on the hex or the chip thinning effect on 10 minutes of tool life. In this example, it's Inconel 718. You can see that the cutting data is much faster, about 30% faster, and you're getting the same performance in tool life. So this slide here shows a test cut with our old grade, comparing it to our new grade, and it's Inconel 718. Now, with this slide, you'll notice that the surface footage is exactly the same. So at 165 surface footage, you're not getting much better performance in tool life. And the reason for that is that this insert wants to be pushed hard. And this is the big thing I wanted to get across in this webinar, is that if you come across our new grade of insert, you don't want to run it like you may have done 10 years ago with older inserts. You actually want to push this thing a lot harder. And if you do so, it's going to yield fantastic results. So here you can see we up the surface footage from 165 to 330 surface foot. And comparing our old grade to our new grade, you can see the tool life is drastically better. You get much better performance, and this insert wants to be pushed at those like 300, 325, 275 surface footage. Here's just another example. This is one of our dog bone inserts, a coral cut 6 millimeter. So it's got a full radius on it, and it was used for doing a finishing cut at 230 surface foot. And you can see, comparing the old grade to the new grade, there's 43% less flank wear. So when we take that under a microscope and measure that area shown in the images, you can see the one insert almost looks brand new still. There's barely any markings on it. Okay. So kind of jumping from there, from the article discussing about the S205 grade, while it's, very important to have the right grades for what you need to be cutting, as it pertains to the 5-axis machine, you also need, the proper holder to uh, do 3+2 turning. So we have all seen, traditional 2-axis lathes, and you come on in at either like 0 or 90 degrees. But here we have a solution called SL70. And what this is a modular holder solution for the aerospace industry. It's specifically designed and made for doing aerospace components, not like what's on the screen, turbine discs, fan discs, things of that nature, where you need something that has a blade that can either do a face groove or a hooked flange groove and reach up underside of a pocket. So the reason we call this the SL70 solution is that the interface that these blades connect to a usually a capto interface, they have an elongated serrated 4-bolt connection, and that serrated connection is 70 millimeters by 40 millimeters, hence the 70 millimeter SL70 name. We do offer the blades in a multitude of sizes. They come all in high pressure connections, some of which come with over and under uh, coolant. Some actually even come with like 3 nozzle high pressure over, 3 nozzle high pressure under coolant. So just giving you fantastic coolant control and chip breaking ability. You can connect those to our SL70 adapters. They're at as you can see here in standard 0, 5, 45, 90, 95, and 135-degree interfaces, as well as we can make any multitude of specials for any kind of particular setup that you need. So connect those to our modular Capto system, and then you can put it on the back end of a, whatever your machine spindle is, be it, Cat 50 or HSK 100, 125, 63, whatever it may be. We have the stack up of adapters to give you a fantastic standard, next day delivery solution that's purpose designed for multitask and 5-axis machines to do 3+2 turning. So not just going in at 0 degrees to the axis of the part spun on the main spindle or radially at 90 degrees, but you can leverage the built-in design of the angle of the holder. Hopefully you can see my cursor moving to get underneath a turn pocket, or to utilize the B axis to its fullest extent, and do an index motion at any. Here's just another example. You can see a couple of holders at a slight tilt at 5 degrees, and another one here that's at 100 degrees. And it really makes it really nice to go into like these, you know, uh, undercut pocket areas for like a turbine disc. Okay. Um, so we talked a little bit about a grade example, a little bit about some of the SL70 holder examples, which are fantastic. But now we need to talk about the turning techniques to use. So it's not just enough to use the correct insert with the correct holder in a multitask machine, but you want to utilize a good technique. One of those techniques is called trochoidal turning. Um, this is something that we've been touting and singing its praises of for decades. And in the last 10 years, we've been able to incorporate into like a dynamic turning technique that you've probably seen starting to roll out with CAM software manufacturers, is that they have things such as like volute turn or adaptive turning, dynamic turning, and it's basically built on this basic concept. So what trochoidal turning is where you take a round insert, and to turn out a pocket, you're basically doing something similar to a zigzag turning process, except you're not zigzagging, slamming it into either side of the pocket wall. You're actually rolling it in and out at a particular radius. Usually that radius wouldn't exceed 50% of the diameter of that insert. And in doing so, it allows you to kind of feather on and off the pocket wall and save the insert tool life. Whereas otherwise, if you were slamming into the corners, this shocked the insert and it would degrade over time faster. So this is a fantastic concept that allows you to not only utilize both sides of the insert, so basically kind of using two inserts in one, It's just very forgiving and allows you to be highly productive, very high metal removal rates. And it really lends itself well to stainless steels, titaniums, Inconels. So really good solution in that regard. So here on the screen, you can see kind of, if you imagine that's a round insert going into a turn pocket, going back and forth, and that's what trochoidal turning would look like on your CAM software. There is another technique called scoop turning, and that's kind of a variation of trochoidal technique where you're only down cutting. So you're only diving into the pocket and then you're lifting up at the midpoint and diving in again. That's another fantastic solution for deep pockets where you may have a really long reach blade that is attached to, and you don't want to go down in the pocket and then drag the insert back up because it puts too much flex and bend moment on the blade. So in certain particular situations, or even for uh, thin walls like seal fins, scoop turning might be the way to go. So just another technique similar to the trochoidal turning. And going beyond that, as I mentioned, a lot of the CAM softwares are rolling out their own kind of version of this that's like a volute turn, dynamic turning that kind of incorporates this technique. Here's just such an example. A lot of the customers that I work with for the engine side of things use Siemens NX. So here's just kind of an example real quick. In Siemens NX, there's pretty much 3 different ways that you could use trochoidal turning. You could draw it out and sketch it in teach mode. This is fantastic because it gives you exact control over the tool path. You could use just a can cycle, your traditional rough turning can cycle, and be able to get pretty close to what the tool path needs to be. You'll notice that it does leave cut on the walls here, kind of retracts and does a little rapid and then goes back in. That can be good or bad. Sometimes when you leave cut, it can be good, but it can be a shock to the insert. So uh, not always the best. And then you can see their new can cycle called rough turn smooth, and this truly incorporates like a trochoidal smoothing technique to make the insert go back and forth tangent to the wall that you're machining against. So just one example in Siemens NX. There are other softwares that can also do this, Mastercam, and others. Um, so we talked about the insert grade. We talked about some 3+2 turning holders solutions, SL70, and discuss some toolpath techniques such as trochoidal turning. But to truly leverage that 5-axis machine, or in this case, a multitask machine, sometimes you're going to want to utilize full 5-axis turning, or what we normally call B-axis turning. So where this comes into play is if you have a critical engine component, for example, and you only have particular areas where you can have a blend point. If you blend anywhere else and have the tool approach or departure, that could be a fracture area or a failure point where a crack could form over time. So you got to be very careful with what areas you go over when you're turning it and keep that tool in contact. So in order to do that, you can use B-axis turning. So B-axis turning in the past, in previous generations, we kind of had to cheat it and use like a 5-axis tool path and get rid of the Y motion and just output like a XZB motion like you see in the example on the screen. Newer generations of machines, it has can cycles built already in the machine and support to do such things. So depending on the age of your machine, or if you're planning on buying a new machines, that should not be an issue. It's just a add-on module that you most likely would purchase if you want to have the capability. And you can now, in the latest version of the CAM software, have support and post out the code. Whereas before you had to cheat it a little bit. So real quick, just as an example, what B-axis turning is not is just an all-encompassing solution. So you still want to 2-axis turn everywhere you can, then use indexing 3-axis turning to pick out different corners and areas, and then utilize the simultaneous B-axis turning just for the finishing operation. my recommendation for most operations. So not unlike 5-axis milling, just because you have a 5-axis milling machine, you actually want to do as much as possible with 2.5-axis milling, and then use 3+2-axis milling, and then and only then use simultaneous 5-axis milling where needed or advantageous. So in this example, you see we pick out the pocket and then we come back in with a finishing operation and we just sweep it to get a continuous nice finish along this pocket area. And then we can come back in with some other inserts and then like pick out the undercuts. Now like with this shown hockey stick insert to get that undercut there. So hopefully on the screen, you'll see this animation move. So here's just another example in Siemens NXCAM. Again, other softwares can incorporate this. Just showing Siemens NX that's a typical CAM software we see with a lot of our aerospace engine partners. So you can just see like a quick example there of it, turning out that inside pocket and making a continuous sweep, so you have no blunt points. Here's just a live demonstration. So hopefully it's coming through on the PowerPoint. You should be seeing a multitask machine turning a turbine disc. So this is an IBR. It's titanium 6L4V. We have it in the SL70 holder like we were discussing previously. And this is on a Mazak Integrax E410 machine. Okay. One other thing I wanted to mention in turning was y-axis turning. So this has been a really neat, a recent development in the field. Maybe you've seen this. Maybe this is something new to you. I know it's so new that a lot of the CAM softwares are still kind of coming up with CAM cycles to be able to support and post code for doing this type of code. So what y-axis turning is as the name implies, you're turning, but you're actually using the y-axis. So you're not using the xz plane, you're using the yz plane. And if you're wondering why in the world would you do that, it's all about the forces. On a multitask machine, like on the image you see here, you have your b-axis, and all your forces, you want them directed up through the b-axis spindle. And in doing so, you can then be much more aggressive with that cutting action and tool on the part. So you can go um, much faster than you otherwise would in the XZ direction. So we've already had y-axis part-off tools that have been released for quite a number of years now, but now we're kind of going full speed ahead into just full-on roughing for turning. So with the capabilities of multitask and 5-axis machines, it allows us to do this. So it's really fantastic. So here's just a quick video. It's going to show an animation of y-axis turning and one of our solutions. We do have a solution available in our prime turning insert. So that's what you're seeing on the screen here. And that'd be a whole nother topic to discuss. Prime turning is just an excellent solution for high feed turning and turning out a significant amount of material. So you can kind of see I get an idea of what the tool path looks like. You notice that these holders actually have two inserts on them, so you can flip it 180 degrees and utilize both sides of the turn tool. So one can rough and do like a trochoidal adaptive turning, and then you can flip it and do a simultaneous like a B-axis, actually A-axis turning operation. So really, really slick solution. Definitely the future. So look out for that. That's going to be something you'll see more and more in CAM software as well as multitask machines. Okay. So with that, I'm going to jump into some milling techniques. So we talked a little bit about turning. Now I want to talk about milling. So just like with the trochoidal turning, that's kind of almost like adaptive milling or dynamic milling. Of course, on a 5X machine, you can do adaptive milling. But what's also been fantastic in recent years is not just the 3+2 adaptive milling, but we can actually do it in full simultaneous 5-axis. So real quick, adaptive milling, what we're talking about here is light and fast machining with a long edge cutter. So normally that's a deep axial cut and a light radial cut. And the benefit of doing that, these light and fast cuts, is that you can maximize a chip thinning effect to where you can increase your feed rate on that tool and get much higher metal removal rates than you otherwise would. And the heat propagation is so low, and your short contact uh, and low temperature from that is so low that you actually get excellent tool performance and tool life. Just showing two examples here. We're looking down on a pocket, and if you notice the tool path on the top, it ramps or helixes into the middle of the pocket, and that does a traditional tool path, kind of slamming in the corners as it works its way out. The tool path on the bottom is more of an adaptive milling tool path, and you can see it does more of a concentric spiral morph all the way out, and then it does these slices to clean up the corners. So much easier on the tool, and just wanted to showcase that with this force output. So the first uh, tool path on the top has force spikes all over the place that are up to 1500 Newton meters. Whereas when you look at the bottom chart with the adaptive milling tool path, yes, it gets those force spikes, but they're not exceeding 800. So half the forces are being seen on that tool. So much easier on the tool. You can push it a lot harder. The tool's going to last a lot longer. It's going to sound a lot nicer. You're not going to get those squawks in the corners that you otherwise would. So just a really good technique to use for machining. So taking that a step farther, we've taken adaptive milling or dynamic milling, waveform machining, volume mill, whatever you want to call it, and made it not just a 3+2 solution, but now a true multi-axis roughing solution. So in this example, in Siemens NX, we can actually follow a curved floor and machine that pocket and machine the curved floor at the same time. Um, so in Siemens X, for example, you have that support. There are other softwares that support it. Mastercam, for example, you can do adaptive milling and have it follow that curved floor. So it's fantastic for engine cases, any kind of bracket that's curved that you need to machine quickly. You no longer have to like point mill it or scrub it with a bull nose. You can kind of just do it all in one shot. So on this example that you're seeing on the screen here, we're looking at a horizontal mill with a tombstone. It's cutting a bracket that's out of titanium 6L4V. It's hard to see the controller interface, but the reason to show that window is just to kind of show that, let me just play it again here, that it's moving in all 5 axes. So it's not only just machining the floor, but it's actually motioning so that it makes this curved floor. So fantastic again for any kind of conical or curve shaped component that you need to machine. So cases, shafts, any kind of bracket with a curved floor. Okay. So with that, I want to jump into another topic and just showcase another solution that Sandvik is releasing just a few months ago. We have a new line of Coromant Plura ball noses specifically designed for titanium and nickel alloys. So this is really geared towards the aerospace industry for milling and finishing like curved 3D shapes. So think turbo machinery. So that'd be your IBRs, your impellers, your shrouds, your bliss, your shrouded turbines, anything like that. These ball noses are fantastic for it. So what makes them so special is they're designed from the ground up with either 4 teeth or 6 teeth. They're neck down or kind of more of a standard ball nose solution. They're edge prep. They're the land, the the way that the center cutting at the tip, the actual hone and like the grind on the curvature is made so that it's much tighter into a tighter tolerance than otherwise would be, so that it's just all geared towards making fantastic 3D profile shapes. So just like you see here on this example, these blisk fins that you should see. So standard release in our catalog, we have ball nose cutters, and we've always offered a huge assortment of um, any kind of special that you'd like to have made. And in this industry, a lot of times we will make it a special just because you need a very particular length to reach diameter to get up and under these kind of like S curve bladed shapes. But we are rolling out more and more standards. And we'll see some more coming here in recent months. So currently we have these standard pleural ball noses. They're, again, fantastic for titanium and nickel alloys. But we do offer special solutions for, lollipop tools, conical ball mills, barrel tools, tangent barrel tools. So a complete, total package to machine turbo machinery. Okay. Again, just some of the, the components that it's used for. You can see all the different stages of the engine. So on the cold side, a lot of titanium components, and then on the hot side, you have, your combustion section, the HRSA, nickel alloy materials. So dedicated MLs for both sides with dedicated grades, one for titanium and one for nickel alloys. Okay. Another example here, just titanium and 718. So dedicated solution for any type of the hub, the root, the edge line. There's a solution for it. One other thing I wanted to touch base on that was mentioned in the article is tulip and fir tree support. So what was mentioned in the CTE article was the ability to uh, make custom tools for fir trees, or fir tree slots, I should say. So these are slots that connect blades on discs. So we have a program to do fast turnaround of these solutions. So we make semi-finishing and finishing solid carbide solutions for fir tree slots. So again, just something to mention that was in the article, just to bring to your attention that we do have solutions for this. They're fast turnaround. We, offer them for years and years, and have a really fantastic competence and experience machining these types of slots. Okay. So now jumping into ceramic milling. So ceramic milling is utilizing ceramic cutters, either solid carbide or indexable. And the benefit is that you can cut very, very fast on nickel alloys. So just nickel alloys, don't use them on titanium. They're not made for that. You need to use them on nickel alloys only. Um, you would want to cut them at around 3,300 feet per minute compared to 100 foot per minute at most for like a end mill. So very, very fast metal removal rates. Pretty much one of the only downsides is that, your tool life is much shorter. So maybe you got 20 minutes tool life before, now your tool life's 3 minutes. However, your metal removal rate is astronomical. It's through the roof, and you can machine a lot of material out very quickly. Some other things to note: you don't want to use coolant. You don't want to climb cut. You actually want a conventional cut and build up a chip in the cutter that's uh, thin to thick. You actually want to build up heat in the cutter and have it, get the chips out of there. And the chips aren't like sixes and nines like your traditional chip. It kind of metastasizes and makes kind of like a sawdust chip. But if you, run it at the high surface speed, no coolant, conventional cut, you can get fantastic metal removal rates. Okay. And we'll kind of show an example here. One other thing to note and watch out for is that typically I see a lot with customers when they're first running ceramic mills that they don't push them hard enough. You can see on this image here on the left-hand side that it's cutting at 2,300 surface foot. On the one on the right-hand side, it's actually cutting at 3,300 surface foot. So when they first cut with ceramic mills, they may see, the typical sparks flying, and it's, unnerving, and think that they need to slow it down, when in reality, you actually want to speed it up. You want to put as much heat into that insert as possible. Okay. So here's just an example. This is a block of titanium. I'm not sorry, Inconel. And why it's so important that you do not use it for titanium, because it will cause a fire. It's only strictly for nickel alloys. So I just want to be clear on that. Um, But when you're utilizing, you don't use coolant. This is exactly how you would cut it in real life, and you're going to see sparks flying. You'll see kind of like this sawdust of sparks, but it's fantastic at removing a lot of material very quickly. Here in this example, you can see we're going 3,200 surface foot, 4 thou per tooth. And many times the inserts are negative inserts, so they're two-sided. So you can get a number of indexes, usually about 4 indexes, if not 6 indexes out of each insert. So again, very economical. So as this pertains to 5-axis machining and milling, uh, we typically do it a lot, on pockets and such, like you see here. But you can also do it for turn milling, which is fantastic. Not only that, we offer ceramic ball nose solutions that you can actually use a ceramic ball nose to semi-finish and like rest rough turbo machinery, not unlike you see in this video playing. So very, very productive, very slick solution to rest mill turbo machinery with a ceramic milling cutter. Okay. So also taking the ceramic mills, we can actually turn mill with them, and this is a fantastic solution for 5-axis machines and multitask machines. So where turn milling comes into play is if you have a component that is just too awkward, maybe it's an L-shaped, like kind of like a landing gear component or like an A arm, or you have something like a casing where you can turn portions of it, but you also have all these bosses and pads and split lines that are in the way. So there's no way that you can turn it. You're going to have to mill it. Traditionally, you might 3+2 mill different sections and then point mill in between eventually to get it milled out. But the more advantageous way of doing things is to turn mill it. And when I say turn milling it, I mean you're taking a cutter, offsetting it off center line, using what we call like the y-axis offset. And as you turn the component, like you see here in this multitask machine, it's grabbed on the main spindle and sub spindle. This nickel alloy component is being turn milled with a ceramic cutter. So there's a large boss pad in the way that you can't turn this middle section. So what you have to do is actually position it so that the cutter is cutting on its leading edge off Y0, where so in this example, if we were looking at a side view of the cutter, it'd be cutting here on this front leading edge where the red dot is, and then the back end of the cutter is hanging off the part. So that's what we're trying to show here on this image. But it's a fantastic solution for milling a lot of material really quickly and even getting an excellent surface finish. So in this example, you're just seeing a ceramic mill and it's just doing a main roughing. We can come back in with a carbide round button cutter, as well as even a shoulder cutter indexable with a wiper. And we can use a wiper insert to give it a fantastic surface finish to where it holds excellent tolerance and it's hard to even see without just seeing the cut lines, the difference between the turned area and the milled area. So excellent solution for, uh, you know, components that have obstructions in the way that you just can't turn. So that especially cases. So it could be conical or cylindrical. Could have bosses or nested bands in the way, split lines, whatever it might be. Just a really good solution, and you can do that because of the capabilities of the 5-axis or multitask machine that you're using. Here's just an example of it programmed in CAM software. So kind of typical, you'd see the tool path going around. And in this particular example, is just trying to miss that boss that's in the middle. And that's why it couldn't be turned. You had to mill all that out of there because of that boss in the way. We do offer a multitude of calculators. This is just an example of one that we utilize for turn milling. This one allows us to predetermine what our step overs need to be for each pass of this cutter to anticipate what the cusp height would be. So if we know what the cusp height is, we know if we're holding to tolerance what is needed on the print of that part. So we can predict exactly what that cusp height is going to be. and optimize the positioning of that cutter. So it's a fantastic calculator at that. It's really good for optimizing, um, your tool path. Okay. So next, I'm just going to dive into power skiving. Power skiving is a really neat solution for multitask machines. What it is it's a dedicated milling cutter to synchronize with your main spindle apart on your multitask machine, and that you can cut and volute splines and gears, either it be OD or ID. Um, and here's a good animation of that. So if you imagine this cutter on your B-axis of your multitask machine, and we're doing an ID involute spline on a part, this cutter will be custom built to match to your involute spline definition. It'll be tipped at a very specific angle, and it'll be synchronized with the rotation of your main spindle to mill out that uh, involute spline shape. So we have a dedicated team with software and calculators that'll be able to predetermine exactly the size and shape of the cutter that's needed. And you can use it for roughing and finishing. So here it's, sped up. This is probably more typical what you would see on the machine, where, it's all spinning really fast and you can't see anything. Here's just a live, slowed down view of what's possible. So you can see they're just spinning in unison, machining that OD spline shape. So really fantastic solution. In the past, you'd have to use a multitude of machines, a shaping machine or a gear hopping machine to make this happen. But now with multitask machines, you do have the capability of doing this right on one machine. There's a couple of examples there. Our Coromant 179 solution, as well as our Coromant 180 solution. And again, we can make these to any kind of custom size and shape to meet your needs for your spline. Okay. And showing this slide again that we showed at the beginning of the presentation, as it pertains to power skiving, you can see that you no longer need the shaping machine. You no longer need a hobbing machine. Maybe you just need a grinding machine if there's close tolerances that you need to hold, but you can basically turn, y-axis turn, simultaneous b-axis turn, 5-axis mill, swarf cut mill, point mill on like a complex curved shape like turbo machinery. You can turn mill, you can skive. So really, run the whole gambit of any kind of, operation that you need to do on a multitask machine. Whereas in the past, you needed, many different machines to do that. So hopefully this was helpful today. If you have any questions or want to investigate further on your own, we do have a dedicated landing page on our Sandvik Coromant website. It's called Aero Knowledge. You can just go to the Sandvik Coromant website as well and just type in the search field, just type in Aero Knowledge, or pretty much any other keyword for uh, maybe a engine component or aerospace component, and it should pop up some useful information for you. Of course, we can be contacted as well. Internet or phone call. I'm sure you have a local sales support who can stop in anytime. But I'd like to thank you again for your time and allowing me to present this webinar. And hopefully it helped and piqued your interest in a couple of different topics. If I can be of any assistance any other way, please just reach out anytime. But thank you again. Thank you,
Thank
CTE.
you.
And
Thank you.
yeah,
Thank you, Tom. Thanks.
yep.
We're gonna see if there are any additional questions from anyone, but that was really a lot of information, really, really quickly.
Yeah, yeah.
And
Yeah, it was,
I particularly like ceramic cutting. I mean, just because of the sparks.
yeah, yeah.
But
It's pretty exciting.
that slow motion at the end, that was pretty impressive.
Yeah,
synchronized synchronized cutting, synchronized um,
yeah,
swimming.
yeah. It's a wow factor. Imagine the way they did it in the past, and now you can just do it all in one five-axis machine. So it's pretty exciting.
So as we talked about earlier, there were a few people who signed up to watch this webinar today who submitted questions in advance. Everyone can see them on their screen right there, but you want to talk about which brands should they consider if building a new five-axis capability?
Well, actually, Sandvik Coromant, we partner with all the major machine tool brands. We stand neutral in that regard as far as recommending a particular brand. However, we can absolutely assist with any particulars. So if you have a part or a family of parts, and you want to do it in a certain amount of setups, we can definitely say you need this size multitask machine with this kind of kinematics. You might want to consider this kind of loader, or these kind of features on the machine, such as power skiving or simultaneous b-axis turning. um, in that regard, there'll be any number of machine tool partners who can assist and take it a step farther, and kind of get into the nitty gritty of what it is they particularly need. So we can help with your power torque requirements and things of that nature. But as far as a particular brand in that regard, we kind of stay neutral.
Right. I mean, it really depends on the situation and whatever
Oh yeah.
their needs are, obviously.
Yep. But we tell everyone all the time, though, you can't contact us early enough. We love to get it on the ground floor, and be able to help you prep and prepare. Um, that really bodes well for your success, and being able to make sure you're getting the right tools, the right machine, the right everything that you need, so that you can be the most productive as possible.
Cool. Second question there was, to what degree are you using step AP242 as part of the process, and any
Uh,
lessons learned from using it?
Yeah, we used Step as our standard format for downloading solid models on our website. Those are all done to the latest ISO standard. Um, with the newer standard format, there's some intelligence built into it, for like mounting datums and building up tool assemblies. Um, but other than that, that's kind of the extent. We do work with any number of CAD files and 3D formats beyond that, and the step file format that you're referring to is just a good general format that you can utilize in any multitude of CAD CAM software. So it's frequently used.
Okay. What role do coatings play in that? Just says play in your approach, but it depends on what approach you're taking. But what role do the coatings play?
When it comes to the coatings on the insert of the grade, it's of huge importance to make sure that you have the right grade coating for your insert. And luckily for Sandvik Coromant, we make a whole bunch of grades for every kind of material that's out there. So we have a, a very good, clear choice grade for a particular part that you're machining, be it aluminum or titanium, stainless steel, nickel alloys, cast iron. We have any number of grades, and they're all purpose designed and have different characteristics that are good for different materials.
So, and I'm not sure if there are any questions that come in from the audience. If there are questions from the audience, just feel free to submit them either through the chat or the Q&A area. But I did want to just ask, from early on in the your presentation, you mentioned the need to really push the tools, some of these new tools that you've come out with,
Hmm.
faster and harder to really benefit from the capabilities of the tool. And I'm just kind of curious, how often do you have to remind customers that they can do that? I mean, how is that a slow
Yeah.
learning curve, or give me some idea how that goes?
Yeah, and that's a great question. Depending on the industry and the customer and what they're doing, some are more on maybe the bleeding edge, I would say, where they're constantly incorporating the latest and greatest and insert grades. But some of these parts in the aerospace uh, industry, especially with like engine programs, they could be parts that have been made for decades. It's not just made for 5 years, 10 years, 20 years. And once they lock in a process, they don't make changes for a very long time. So it is. Quite a task for us to kind of like educate some customers on what's out there, because they might not have looked at a part process or had it locked in for 5, 10 years, and things have moved on so far just in the last 3 years, that you can really push the inserts harder, push the tools harder than you otherwise ever could. And it's kind of a shock to them sometimes, because they think that okay, I can move it maybe 10% faster, and it's like, no, you can really dial it up and go a lot faster than you think you otherwise could. And in some cases, like the example I gave, it's to the detriment of the insert. It wants to be pushed at a certain surface footage and in feed rate, and if you're not pushing it into that window, then it'll actually degrade and not work as well as it otherwise would.
It's interesting that you're saying how fast things are changing, and it often seems to me, and I'm the publisher here, that we cover a lot of the same kind of articles from you give a 5-year time span, and you'll see some of the similar headlines anyway, um, covering some of the same approaches and strategies, but just a little different every time. And obviously, there's a reason for that. Things have been really changing and evolving pretty rapidly, and it's important to keep up. And with whatever the new technology is, and how to use the new technologies
Hmm.
for their own benefit, to be more productive. So, for your customers, you've got this Aero knowledge and these calculators on your website to kind of help them sort through their best approach.
Hmm.
How long is your that website, the Aero knowledge? How long has that been around?
Oh, that particular website's, I think, been around for about 7 years, and we have a number of different splash pages within our Sandvik website as well, that has just a huge breadth of information from any number of different materials or industries, especially aerospace.
Yeah.
But yeah, I know, so it can be a little daunting sometimes on that website. So please, reach out to us anytime. Email, call us. We'll have a local representative visit your office, and be able to help you out in any way that we can.
Okay. Well, I don't see any questions coming in. I just want to check one more time. And that's fine. If anyone does have a question, if we can, I'm just going to suggest that the questions you can submit directly to Tom. His contact information is right there, tom.funky@sandvik.com, and that's
Yep.
funky with an E, uh, for his email address. And his phone number is there as well, if someone wants to reach out. Email is probably a good way to contact you, isn't that right?
Yes.
Okay. And I really appreciate you taking the time to share this with us. It again, I like doing these things just to give our CTE magazine audience a chance to contact directly with some of the people who we interview for articles and who write articles for us, and that's the case here. But I think it's a great way to expand on the information that we're providing. So I hope that our audience has appreciated this webinar. And if you're watching the video version, just again, if you have a question, reach out directly to Tom about this, or if there's something that CTE can help you with, by all means, reach me at dspaith@ctemedia.com, or use my phone number. So, with that, uh, Thanks again to Tom. If anyone is out there and they're interested in watching another one of these webinars in the future, we have another one coming up on the 28th of August that will be based on or build on the July feature article that we have coming out shortly on rotary broaching and some of the benefits and the perils in rotary broaching. So keep your eye out for that. And again, thanks a lot. Tom, is there any other thing you would like to add signing off?
Please contact us anytime. And thank you so much for your time today, everyone. And thank you, Dennis.
Thank you, Tom. Again,
Yep.
thanks everyone for taking some time and sharing that with us today. Take care.
Okay. Thank you. Take care.
Bye-bye.
Bye-bye.